Hello guys, today we are going to discuss this problem, minimum cost to make array equal. So the problem says is that we are given two arrays, that is a nums and a cost array, and each will have the positive integers. So we can perform only two operations on nums array. That is, we can either increase the nums array number by 1 or decrease the nums array number by 1, and we are given an associated cost of doing such operation in the cost array. For example, if we reduce this 3 to 2, then we'll have a cost of 3, and then we have to return the minimum cost such that all the elements in the nums array becomes equal. All the elements in the nums array becomes equal. So so how they have given the example, let's take an example here. Okay, so they have given the nums array and the cost array, and now we have to find the cost when making all these elements equal on the nums array. So what we can do on nums array, we can on nums array what we can do, we can either make um, all ones. So for example, if I make this one, keep it this one, then if I make this one, so what I'll do is I'll make this 3 as 1. So for making this 3 as 1, I'll do it first as 1. Then okay, let me okay. So I'll have 1. Then for making 3 as 1, I'll reduce it by 1, so it will be 2. Then let me keep 5 and 2 as it is, right? So the cost associated with uh, changing from 3 to 2 will be 3. So it will be the cost will be 3 here. Then on the next step, let me again make 2 to 1. So it will be 5 and 2 again. So the cost associated with changing this 2 to 1 will be 3 again, right? So 3 is changed to 1. So now let's change this 5 to 1. So it will be 1, 1. Now it will become 4 and it will become 2. So the cost associated with changing 5 to 4 is 1, because in this array we have 1 here, associated 1. Similarly, we'll have 4 steps. 1, so now this will become 3, then this will become 2, and then this will become 1. Sorry for my poor drawing. So the cost associated with changing 5 to 1 will be 1, 2, 3, and 4, right? So the cost associated with changing 2 to 1 is 6, because we have 2 steps. Cost associated with changing 5 to 1 is 4, because we have 4 steps, and each costs it 1. And cost associated with changing this one to 1, because finally we have to make it all the elements as 1, 1, 1, and 1. The cost associated with changing this 2 to 1 here is 14, and we do not have any cost associated with changing 1 to 1 because it's already there. So what is the total cost? Total cost is 24, right? Now let's consider changing um, to 2. Okay, so we have 1, 3, 5, and 2. So now we have to change everything to 2. So in this one, we'll change 1 to 2 in one operation, then 3 to 2 in one operation, 5 to 2 in 3 operations, and 2 to 2 in 0 operations. So here what we'll have is 1 to 2 in one operation, 3 to 2 in one operation, 5 to 2 in 3 operations, and 2 to 2 in 0 operations, right? So 1 to 2 associated cost is 2 plus, because this is 1, so we'll multiply it by 1. Then we have 3 to 2, it will be 1 operation multiplied by cost of one operation, 3. Then 5 to 2, these are 3 operations, so we'll do it 3 operations multiplied by done 3 times, plus 0 because 2 to 2 is not changed. So the cost here in this one will be 8, right? So cost of changing all elements to 1 is 24. Cost of changing all elements to 2 is 8. And similarly, we'll see cost of changing all elements to 3, 4, 5, and so on will increase. So our answer is minimum. This is our answer. So this is actually the question explanation. Let me tell that how we are going to approach this problem. So we are going to approach this problem in um, the weighted median. We are going to find the weighted median in this question. Okay. So first of all, let's see what is a convex function. So this problem is basically about the convex function and the weighted median. So why this problem is about convex function? Okay, let's see. So if we see, this cost can be imagined as a frequency, so we can say it as a frequency as well, right? Frequency of operations. So if we consider this cost as a frequency and these are the numbers, so we can write this as uh, two frequencies, so it will be 1 and 1. Then for this 3, we can write it as 3, 3, and 3. For this 5, we can write it as 5 only, and for this 2, we can write it as 14. So we'll write 2 14 times, right? And so on up to 14 times, right? So now the problem is that we have to convert all the elements to any single element, right? So if you want to convert all the elements to 1, so this will remain 1, 1. This will be changed to 1, 1, 1. So the cost associated will be 2, 2, and 2. So this will be changed to 1, the cost associated will be 4, and all these will be changed to 1, 1, and so on up to 1. So the cost associated will be 14. So the total cost associated with changing to 1 will be 6 plus 4, 10, and 4. So it will be 24. Now let's consider the cost associated with changing it to 3, right? So for changing it to, so cost associated with changing to 1 is 24. Let us note it down. Cost associated changing it to 3. So this will become 3, 3. So the here cost will be 2. Here will be 2. These all will be 3, 3, 3, 3. So this is already 0. No, we do not perform any operation. This will be 2. And for these 2's, this will be um, 1, all ones. So 14 times 1. So this will be 14. So it will become 3, 3, and so on up to 3. So the total cost associated with changing to 3 is 2 plus 2, 4, plus 2, um, 6, and plus this becomes 20. So cost change associated with changing it to 2 becomes 20. Now let's consider the cost associated with changing on 2. So on changing to 2, it will become 2, 2, it will become 2, 2, and 2, it will become 2, and these all will be zeros. So the cost associated will be 1, 1, so it will be 2. So these are 1, 1, and 1, so it will be 3, and this will be 3. So cost associated will be 8. So cost associated for changing with 2 is 8, right? Now let's see the cost associated with changing to, let me select and delete, cost associated with changing to 1, 2, 3, 5. Let's see 5. So cost ratio we're changing it to 5. So it will be 4 and 4. So it will be 8. So this will be 5, 5, and 5. So these will be 3 2 and 2, it will be 6. So cost it will be 0, and cost associated with changing all these 14 twos to all fives will be, for 1 it will be 3 multiplied by 14, right? So it will be equal to 3 into, so this is arrow, 3 into 14 is 42. 42 plus 8 is 50, plus 6 is 56. So for 5 is 56. Okay, now let's consider one more time cost associated changing it to 4. So I'll tell you why I'm telling for 4. So let's change it to 4. So it will be 3 and 3, 6. So these will be 3 fours. So it will be 1, 1, 1. So it will be 3. Changing it to 4, it will be 1. And changing all these 2's to 4's will be equal to 2 multiplied by 14. So it will be 28 um, plus 10, 38. So it will be 38. So if we see here, and if we arrange these in a ascending order, so we have 1, 2, 3, 4, and 5. So 1 is 24, 2 is 8, 3 is 20, 4 is 38, and 5 is 56. So if you can see here, this is a kind of a convex function, right? So we have a value which is up, then it goes down, and then it starts increasing and keep on increasing. So this is a kind of this function, convex function, right? So we have to find the base of the convex function, or this is called the weighted median. So what happens here is, if we have um, two elements which are on the base, so we need to find the minimum of these two elements. So minimum of these two elements is 8, which is our answer, right? So um, okay, so how we are going to approach this problem? Let me now select it again and delete it. Okay, so now we have this array 1, 3, 5, and 2. So what we are going to do is, we are going to do a binary search here. Why binary search? Because we will have it in log and time. So for binary search, our low will be the lowest element, which will be 1, and high will be our highest element in the array. So high will be equal to 5 plus 1, which will be equal to 6, right? So we'll do a binary search on 1, 2, 3, 4, 5, and 6. So this is our low, this is our high, right? So we'll calculate a mid. So 7 plus 6 plus 1 is 7, by 2, this is our mid. So we'll check the cost of changing all elements equal to mid. So cost of changing all elements equal to mid is 20. So we'll keep it 20. Then we'll calculate cost of changing all elements to mid plus 1, that is 4. So it will be 38. So we found that cost of changing elements is on mid plus 1 is more than mid. So we'll move on to left, right? So now let me stretch this. So now what will happen? We'll take our high as this, and our low is already this. So our high becomes 0, 1, 2, and our low is 0. So our mid becomes here. So our mid comes here, right? So now we know, so we'll again calculate the cost of making all elements equal to mid, which is equal to 8. Then we already know cost of changing all elements equal to 3, which was 20, and this was 38. So we see that the right element is greater than the left element. We will again move on to the left. So now we have our left here, and we have our right here or high here, low or high, and now our mid will be equal to 0 plus 1 by 2, which will be equal to this mid, right? And we'll calculate the cost of um, making all elements equal to 1, which was 24, right? And now, so now what happens is, since we have 24 on the right of a smaller element, that is, left is greater than the high, so we'll make left is equal to mid plus 1. So our high was here, as we do in binary search, right? And we'll do our low as also here, and then we'll exit the loop, because in the loop we'll play on this condition while left or low is smaller than high. So when we'll exit the loop, in that case we'll see that where is our mid. Our mid was on this left, and we'll return minimum of cost of mid, or cost of mid plus 1, right? Because, so in this case we'll return it. Why this condition? uh, why this condition? Let me choose a different color, because we know, we have already seen that there is a convex function, right? So in convex function there can be two values, or there can be, if for example there can be one value or there can be two values. Two values in case of a array is even, one value in case of a array is odd. So whenever we have two values at the base, all the values will start growing after these two values. So these are the base values of the convex function, and hence we'll return either of the smaller of these two. Okay, so let's move into the code and see how we are doing. Okay, so we have the nums and the cost array. Vi is just vector of int. I have taken it as a type def. Initially, for doing a binary search, I have calculated the low and high. So low will be any number which is lowest in the nums. So in this case, it will be 1, and high will be 5. So if low is equal to high, it means all elements are same. We are going to return 0, and we are going to change high plus 1, right? So this is our binary search. We are going to calculate mid. Then we are calculating cost of making all elements equal to n. That is, all elements equal to mid. This is the n here. So now how this function does the calculation? So we need to make all elements equal to mid. For example, in this case, we have 6 plus 1, 7 by 2, which is 3. So we need to make all elements equal to 3, right? So how it happens is, we have n, so we are going to calculate all for the all elements absolute of num psi minus n. So initially, let me explain it here only. So at I equal to 0, uh, nums will be 1, right? N will be 3, and cost will be 2. So we are going to calculate nums minus n, which will be equal to nums minus n, which will be equal to 2, and we are going to multiply it with cost. So we are going to multiply it with 2. This means what? Let me go back here. This means what? We have our array 3, 1, 3, and something as 5 and 2. Now we are changing this first element to 3. So for changing it to 3, we have our cost array, which was how much? Cost array was 2, 3, 1, 14. So this will have two operations, and we are going to multiply it by 3, right? Sorry, we are going to multiply it by 2, because cost of changing 1 to 2 is 2, then cost of changing 2 to 3 is 2. Similarly, here we are not going to do anything. For this 5 to change to 3, we'll have two operations, that is, one is 5 to 4 and 4 to 3, and then we'll multiply it with cost of each operation. And then for 2 to 14, oh sorry, 2 to 3, we are we'll be having one operation whose cost is 14. So finally we are going to sum all these and we are going to return it. So we are going to return this cost, sum all of them and return this cost. So we got the cost, and we are going to calculate the cost of mid plus 1 as we already discussed. So if the cost of mid plus 1 is greater than the cost, that is cost of mid plus 1 is greater, so we are going to move left. So high is equal to mid. Otherwise, if cost of mid plus 1 is smaller than the left or the mid, we are going to jump to right. That is low is equal to mid plus 1. And whenever the condition breaks, that is low is smaller than high, low becomes equal to or greater than high, then we are just going to return minimum of these two. So this is how this convex function and weighted median is calculated on this problem. The time complexity of this problem is O of n, because we are at least going once in this array, and here we are going to calculate the cost in log n time. So on plus log n becomes O of n. Thanks a lot. Have a good day. Bye.